Hello everyone, I am Anushka. Today I am solving the first internal test paper of Introduction to Data Science. In this video, we are going to solve the part C of this question paper, which is data pre-processing for feedback analytics. So let's start. Here, we have to solve the question number 9, student faculty database. Data may suffer from issues like accuracy, completeness, and consistency. Discuss each issue in this context. Example, missing survey response contradicts proposed two other dimensions of the data quality relevant to learning analytics. So the answer for the data quality dimension concept is garbage in and garbage out. You need to clean data to get good results. Accuracy, the data should be correct and precise. Issue is errors like information lost during power outage or crashed services. Completeness, the data should not have missing values, issues, missing survey responses, or null fields. Consistency, the data should be compatible, issues comparing apples to orange, example, different units like metrics versus imperials. So the two other dimensions proposals is validity. Does the data pass sanity check? For example, a student age cannot be negative or 200. So I think this is a good validation and other dimensions. And the second one is timeliness. Is the data current? Models should be live or they incorporate new information. Old feedbacks might not reflect current teaching qualities. So now move to the next question. Question number 10. Handling missing student feedback values. Discuss approach such as ignoring tuples, filling manually, filling with constant, mean, median, mode, imputation, class-specific imputation, or more probable value method. Now, handling missing values. The concept is you can't analyze empty cells, and the data imputation sections provide these strategies. First, ignore the tuple. Drop all records containing missing data. When to use, you have to massive dataset and losing a few rows doesn't hurt. Then, second number is filling manually. Heuristic based guessing based on the domain knowledge, and small dataset where you can research the correct value. Fill with mean and median, filling with the data with the mean. The data is numeric and symmetric, use mean, or squid, use median. The fourth one is most probable value, that is interpolation. Used a regression model or the nearest neighbor to predict what the missing value should be based on similar data points. Now move to the next question, question number 11. Consider feedback rating, same as question number 2. First is smooth the rating using bin means with the bin depth 3, illustrate steps, and question number B is suggest the way to detect outliners, example, abnormal high or low satisfaction. Question number C is discuss other method for data smoothing. So now answer this question. The concept is binning transform specific numerical value into bordered categories like buckets to reduce noise. So smoothing with bin means depth 3. The first step is sort the data, and the data is you can see on the screen. Then step number 2 is split into bins of 3 items, depth will be 3, and the step 3 is replace all value in the bins with the average mean of that bin. So you can see that we create a 3 bins. In all 3 bins there are 3 data, which is 13, 15, and 16 in bin number 1, and 16, 19, 20 in bin number 2, and 20, 20, 21 is bin number 3. And we calculate all 3 bin means. That is, for first bin mean is 14.6, and second bin mean is 18.3, and third bin mean is 21, and we replace these mean value with the original data values. Continue this logic for all bins. The last bin will be 43, 50, 70, and the mean will be 56. Now, the B is outliner detection. Method is to run a sanity check or use descriptive statistics. The observation is the value 70 is far higher than the rest. We can detect this using the interquartile range IQR or simply by seeing it as far from median 25. And other smoothing method is clustering and regressions. Clustering is grouping point and treating them as a single cluster center, and the regression is fitting a line to the data, then y is equals to beta O and beta 1x to smooth out fluctuations. Now move to the next question, question number 12. In data integration for MTech and MCA analytics, discuss schemes integration, handling redundant data, example, duplicate entries from multiple survey, and resolving conflicts in values. Answer is concept behind this question is combining data from different resources. The first one is scheme integration, solving name conflicts. For example, database a user use a John Smith, but database B uses Smith Johns. You must unity the format. Second one is handling redundant data, using correlation analysis to see if the two attributes are actually the same thing, example, age and date of birth. Third one is resolving conflicts, fixing unit mismatches, for example, converting metrics to imperial or adjusting currency to inflation. Now move to the next question, question number 13. Discuss normalization method. A is min-max normalization, C is z-score normalization using mean absolute deviation, B is z-score normalization, and D is decimal scaling. So the answer is normalization is a data pre-processing technique used to scale numeric attributes to a common range, example 0 to 1 or distributive. This is a crucial because many machine learning algorithms like k-nearest neighbor or neural network perform a poorly where the input features have vastly different scales. First one is min-max normalization. The definition of min-max normalization is the method perform the linear transformation on the original data with the scale of the data to fit within the specific range, typically 0 to 1. The formula of the min-max normalization is as on the screen you can see. Now, the key characteristics is it preserves the relationship among the data values exactly. However, it is highly sensitive to the outliner, which can squeeze the rest of the data into the tiny intervals. The second one is Z-score normalization, then the zero mean normalization. The definition of Z-score normalization is the technique normalize values based on the mean and standard deviation of the attributes. It performs the data so that it can has to mean of 0 and a standard deviation of 1. And the formula for Z-score normalization, as you can see on the screen, where mu a is a mean and lambda a is a standard deviation. Key characteristics of Z-score normalization is it is useful when the actual mean and maximum of the attributes are unknown or when there is a outliner that dominates the min-max scaling. Then third one is Z-score normalization using mean absolute deviation, that is MAD. The definition of Z-score normalization using mean absolute deviation is a variation of Z-score that replaces the standard deviation sigma with the mean absolute deviation. The formula for mean absolute deviation is you can see on the screen where SA equals to 1 by n sigma n to 1 and the vi minus mu a, average distance from the mean. The key characteristic is this method is more robust to the outliner that standardizes the z-score because standard deviation squares the error exaggerate the extreme value, whereas MAD treats deviation linearly. The fourth one is decimal scaling. The definition of decimal scaling is this method normalized by moving the decimal points of the value to the attribute. The number of decimal place move depend on the maximum attribute value of the attribute. The formula of decimal scaling, as you can see on the screen, where j is the smallest integer, such as max b, is greater than 1. The key characteristics of decimal scaling is it is a simple and intuitive, keeping the numerical sequence visually similar to the original data. For example, 98 become 0.98. Now move to the next question. Question number 14. Normalize the following faculty workload value R per semester, which is 200, 300, 400, 600, 1000 using A to D method. So here's a data set you can see on the screen, and the step is to calculate the basic statistics. The count is 5, the minimum will be 200, and the maximum will be 1000. And the mean of this data set is 500. And we calculate the standard deviation also for this data set is 316.23. And the mean absolute deviation for this is 240. Now we calculate the min max normalization from range 0 to 1. We have the formula for min max normalization, and we have to put the values in this. One by one, we solve for all the dataset value and get the answer. For 200, it is 0. Point 0, for 300, it is 0.125, and for 400, it is 0.25, and for 600, it is 0.5, and for 1000, it is 1. Now move to the B, Z-score normalization. Here also we have the formula of Z-score normalization, and we just put the values on this formula. For all the dataset, we calculate the Z-score normalization value, which we can see that the starting three ones are negative and the last two ones are positive. Now, C, Z-score normalization using mean absolute deviation. Here we also have the formula of Z-score normalization using MAD, and we calculate the result you can see on the screen, and same for decimal scaling. We calculate all these four normalization methods. Now move to the next question. Question number 15. Using the feedback ratings, dataset normalize the value 35 using first min-max normalization, B is z-score normalization, C is decimal scaling, and D discuss which method is most appropriate and why. So the given statistics from the question number 2, the dataset range, the minimum is 13, the max will be 70, and mean will be 30.15, and standard deviation will be 12.94, and the targeted value will be 35. Now we calculate the min-max normalization scale value to a 0 to 1 range based on the minimum and maximum. We put the values in the formula and we got the result is 0.386 as the min-max normalization. Now z-score normalization, we got the result is 0.375. For decimal scaling, move the decimal points based on the maximum value 70, 2 digits, so divided by 10 to the power 2, which is 100, so the result will be 0.35. The fourth one is which method is most appropriate. So the z-score normalization is best. Why? The dataset contains the outliner 70, which is much higher than the rest, and the min-max is a sensitive outliner. The largest range is 70 to 13, squeezes the normal value together. While the z-score handle outliner better by using the mean and standard deviation, preserving the distributions of the normal data. Now move to the next question, question number 16. Using age and productivity data from question number 4, A, normalize both attribute using z-score normalization, B, compute personal correlations, coefficient and covariance, comment on whether the relationship is positive or negative. So the answer is given data n equals to 18 and the age is mu x equals to 43.44 and sigma x equals to 13.22. The productivity mean is 28.78 and the productivity standard deviation is 9.325. So the statistics for age is the mean is 46.44 and standard deviation is 13.22, and the standard deviation statistic for productivity as 28.78 and standard deviation will be 9.25. So the third one is Z score calculation. We applied the formula to the every data points and for age and productivity for both, and we get the Z score is minus 1.77 for age and minus 2.08 for products. Now you can see the normalized data table for Z score on the screen. The B is covariance and personal correlation. So the covariance is the formula you can see on the screen. We put the value in the covariance formula and get the result is 100.02, which indicates a variable change in the same direction. Second one is personal correlations. The formula of personal correlation, as you can see on the screen, and we put the calculated covariance to the in this formula and get the result is 0.818. The conclusion is that there is a strong positive correlation. Older students in this group tend to report higher learning productivity. Now move to the next question, question number 17. Student project evaluation scores are 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, and 215, and the partition into bins using equal frequency partition. Then B is equal width partition and C1 is clustering. So you can see the dataset and it has total 12 items. The first one we have to partition into bins using the equal frequency partition. So the action is the 12 items have 3 bins and per bins have 4 items. So you can see we have created a 3 bins which has contained a 4 items. Now in B, equal width partition. The goal is to the same numerical range size. Action is the range is 0 to 220 and the width is bin width is 70. The bin 1 is 0 to 70 which is crowded, and bin 2 is 71 to 140 which has only 2 items, and bin 3 which is 141 to 210 has only 2 items. Now using clustering, the goal is to group by similarities, distance. Cluster 1 low 5 to 15, cluster 2 middle 35 to 92, and cluster 3 is high 204 and 215. Now move to the next question. Question number 18. Use the flowchart to summarize the attribute selection technique for feedback analysis. A is forward selection, B is backward elimination, and the C1 is hybrid method. Attribute selection flowchart. The concept is to choose the best variable to improve models. First one is forward selection. Start with empty set, add the single best variable, and repeat until the performance stop improving. Second one is backward elimination. Start with all variables, remove the least useful variable, highest value, and then repeat. And the hybrid is add best variable, check if any old one can now be removed, and then repeat. Now we complete all the questions. Thank you.